Good day, everyone. My name is Dave Austin Arsaludes from BSEMT 3B4, and today with my groupmates we are going to be presenting our research title for proposal. Our research title for proposal is all about the design and developing an automated Abaca fiber cutting machine. This video presentation will include the discussion of the title, background and rationale, problem statement, objectives of the study, conceptual framework, the review of related literature, and its design.
Background and rationale. There are 5 statements that I will share inside the background and rationale. Number 1, Abaca in the Philippines. Abaca in the Philippines, or they called it Manila hemp or Musa. Abaca comes from a species of inedible native banana in the Philippines. Over 200,000 Filipino farmer families produces Abaca fiber as the main source of income. So number 2, Abaca fiber. Abaca fiber. The Philippines are one of the many countries that abundant of Abaca plantation, and also the Philippine nation can approximately supply 90% of the world's Abaca fiber. So number 3, the traditional way. Traditional way. The companies who are making Abaca fiber to make an Abaca paper and Abaca face mask are using dagger, machete, or sundang and scissor as the manual operation to cut an Abaca fiber in 1 inches to 2 inches of length. Number 4, automatic cutting machine. Automated Abaca fiber cutting machine will have a major contributor to the production capacity of industrial companies. This cutting machine is used to make the paper production faster and reducing effort to a certain process. Abaca fiber cutter plays an important role to cut Abaca faster and accurately. Number 5, the importance of Abaca fiber. Abaca fiber can also use to make a face mask, especially nowadays that we are in the health emergency. Abaca is a leaf of fiber composed of slim cells that form a part of the leaf support structure. Lignin content is high, 15%. Abaca is prized for a great mechanical strength, resistant to salt water damage, and long fiber length up to 3 meters.
Hi sir, I'm RG Lanara from MTTP4. So now I'm going to tackle about our problem statement. So the automated Abaca fiber cutting machine is a machine that designed to cut Abaca fiber more quickly while using the pure manpower. The following questions were considered during the production of this study. The first question is, what design parameter to consider in order developing the automated Abaca fiber cutting machine? So what are the aspects should be taken, or what factors to be considered in designing an automated Abaca fiber cutting machine? The second question is, what development and implementation strategies to ensure that the automated Abaca fiber cutting machine will work? The point is, what tactics should be used or methods should be used to ensure that the automated Abaca fiber cutting machine will work or function properly. The third question is, what evaluation parameters to consider in order assessing the performance and efficiency of the machine? Meaning, what criteria or standards should be used in evaluating the machine's performance. So that's all the 3 questions.
Good morning, I am Julian Solita. Today I will reporting the objectives of the study. The main objectives of our research is to create an automated Abaca fiber cutting machine. The following are these project development aims: to design and innovate new additional features for more productive and safe automated Abaca fiber cutting machine. Second is to develop a fast, efficient, and modernized Abaca cutting machine. Last is to evaluate fast, efficient, and functionality of the automated Abaca fiber cutting machine.
The conceptual framework. The conceptual framework used in this study is the input-process-output relationship. First are the inputs, which are the baseline research, data gathering, and materials, while machine design, developing, and testing are the process, and the outputs are the complete prototype, evaluation, recommendation, and efficiency result. Next is the machine flow process. In the machine flow process, first is the motor. The motors will make the conveyor run, then the conveyor will bring the fiber to the cutter. But before the fiber will be cut, the sensor will sense it if it is in the right size or length. Then the cutter will cut the fiber, and after that the conveyor will bring out the fiber.
Review of related literature, fiber cutting mechanism. We are using rotary blade cutter and test housing for the blade. When Abaca fiber passes through in it, the motor will pull the rod that makes the cutter bend down to cut the bundled fiber. Cutting processes of natural fiber reinforced polymer composites. We will bundle the fiber and we will put it into conveyor belt and it is considered as the feeder. When the fiber will reach into cutter, the output of the fiber will be 1 to 2 inches length. Natural fiber cut machine, semi-automatic, linear motion system for empty fiber bunches, redesigned for local use. In some factory company who are using Abaca fiber as their main product, they are using semi-automatic machine, while our machine is designed fully automated. Understanding conveyor system. This machine is using through conveyor system for the input or the feeder and flatbed conveyor for the output. Conveyor controls using basic motor control, programming, and motors. Design. This is the sample design of automated Abaca fiber cutting machine. For the input, we use through conveyor belt system. It is considered also as the feeder. We choose this conveyor system because of the bend design for better grip. We will bundle the fiber for fast production and better cutting. The head, pulley, and drive is one who will make the conveyor rotate. The conveyor belt is being supported by the throttling carrying idlers. For the cutting mechanism, we use rotary cutting. The blade rotates continuously. It is connected to the motor with tooth belt driven to lessen the vibration. In order to achieve the desired length of the fiber, we are using shock encoder sensor. It is connected to the motor. After the fiber is being cut, it will transfer into flat conveyor belt.